Welcome to our deep dive into the science behind hurricanes, where we unravel the complexities of one of nature's most powerful phenomena. In this video, we will explore how hurricanes are formed, the conditions that fuel their development, and the intricate anatomy of these storms. From the warm ocean waters that act as their power source to the Coriolis effect that gives them their spin, we will break down the science in a way that everyone can understand. Join us as we also examine the dangers they pose, like storm surges, and how climate change is shaping the future of hurricanes. 1. Understanding hurricanes. Nature's fury. Hurricanes, also known as tropical cyclones or typhoons depending on the region, are formidable natural phenomena. These are large, organized systems of clouds and thunderstorms, distinguished by their well-defined circulation pattern that forms over warm ocean waters. The term hurricane is specific to the Atlantic and Northeast Pacific, while typhoon is used in the Northwest Pacific, and cyclone in the South Pacific and Indian Ocean. These storms are not just a collection of winds and rain. They are massive engines fueled by the heat and moisture of the ocean, capable of causing widespread devastation and disruption to human life. 2. The perfect storm. Conditions for hurricane formation. Hurricanes require specific conditions to form, and one of the most critical is the temperature of the sea surface. The water must be at least 26.5 degrees Celsius, 80 degrees Fahrenheit, to provide the necessary heat and moisture to fuel the storm. This warmth is essential because it influences the evaporation rate, which in turn feeds the storm with energy. Additionally, hurricanes require low wind shear, which means that the speed and direction of winds must remain relatively constant as you move higher in the atmosphere. A pre-existing weather disturbance, like a tropical wave, is also necessary to kickstart the process, as it provides the initial rotation and lift needed for the storm to develop. 3. Anatomy of a hurricane. A closer look. The structure of a hurricane is both fascinating and formidable. At its core is the eye, a calm area with clear skies and light winds, often deceiving those who experience it. Surrounding the eye is the eye wall, a ring of intense thunderstorms where the most severe weather occurs, including heavy rain and powerful winds. Extending outward from the eye wall are the spiral rain bands, which can stretch for hundreds of miles and are responsible for much of the rainfall associated with hurricanes. This organized structure is crucial for the storm's survival, allowing it to maintain and sometimes even intensify as it moves over warm waters. 4. The power source. Warm ocean water. Hurricanes derive their immense power from the heat of warm ocean waters. The process begins with the evaporation of seawater, which adds moisture to the atmosphere. As this moist air rises, it cools and condenses, releasing latent heat. This heat release is what powers the hurricane, creating a cycle that draws more warm, moist air into the system. The energy from this process is so substantial that a mature hurricane can release as much energy as several nuclear bombs every second. This relentless energy drive is what makes hurricanes such powerful and potentially destructive forces of nature. 5. The spin factor. The Coriolis effect. The Coriolis effect, a result of Earth's rotation, plays a pivotal role in the formation and maintenance of a hurricane's structure. This effect causes the storm to spin, providing the necessary rotational force that helps to organize the storm's structure. In the northern hemisphere, hurricanes rotate counterclockwise, while in the southern hemisphere, they spin clockwise. Without the Coriolis effect, hurricanes would lack the organized rotation necessary to sustain themselves, and their distinct spiral shape would not form. This phenomenon underscores how interconnected our planet's systems are, with the rotation of the Earth influencing weather patterns on a grand scale. 6. Measuring the beast. Wind speed classification. Hurricanes are classified by their wind speeds using the Saffir-Simpson Hurricane Wind Scale. This scale helps to categorize the potential damage and flooding a hurricane can cause based on its sustained wind speeds. The scale ranges from Category 1, with winds of 74-95 miles per hour, to Category 5, with winds exceeding 157 miles per hour. Each category represents an increase in intensity and potential for destruction. Understanding this classification is crucial for preparing and responding to hurricanes, as it provides a clear indicator of the storm's potential impact on communities and infrastructure. 7. The threat of storm surge. One of the most dangerous aspects of hurricanes is the storm surge, a phenomenon where the storm's winds push seawater onshore, leading to a rise in sea level. This surge can cause severe coastal flooding, often resulting in significant damage to property and infrastructure. The height of a storm surge is influenced by the intensity of the hurricane, its forward speed, and the shape of the coastline. In extreme cases, storm surges can inundate entire communities, illustrating why they are often the most life-threatening component of a hurricane. Preparedness and early warning systems are vital to minimize the loss of life and property. 8. The life cycle of a hurricane. The typical lifespan of a hurricane can vary, ranging from a few days to several weeks. Initially, they form over warm waters, where they gather strength and sometimes grow into powerful storms. As they move, they can intensify, reaching their peak when conditions are optimal. However, once a hurricane encounters cooler waters or makes landfall, it begins to weaken. Without the warm ocean waters to fuel it, the storm loses energy and gradually dissipates. This life cycle is a natural process, but it can have profound impacts on the regions it affects, leaving behind a trail of destruction and a need for recovery and rebuilding. 9. The calendar of hurricanes. Hurricane season. The Atlantic hurricane season runs from June 1st to November 30th, with peak activity typically occurring in September. During this period, the ocean waters are warmest, providing the ideal conditions for hurricane formation. The Pacific hurricane season follows a similar timeline, although there are variations depending on the specific ocean basin. Understanding the timing and likelihood of hurricanes is crucial for preparedness efforts, as it helps communities and individuals take proactive measures to protect life and property. Despite advancements in prediction and tracking, the unpredictability of hurricanes means that vigilance during this season is essential. 10. Climate change and its impact on hurricanes. Climate change is playing an increasingly significant role in the dynamics of hurricanes. Rising global temperatures are leading to warmer sea surface temperatures, which can result in more intense and potentially more frequent storms. Additionally, rising sea levels exacerbate storm surges, increasing the potential for coastal flooding and destruction. There is also evidence suggesting that hurricanes are lingering longer over affected areas, compounding their destructive potential. These changes underscore the importance of understanding and addressing climate change, as its effects on hurricanes pose significant challenges for communities worldwide.